This is fun to say when describing a toroidal universe where living in a giant donut, Homer Simpson was right. But this inevitably gets a bunch of people saying, what if you travel through the middle of the donut? And that's why I have to make this clarification. First of all, the donut, the torus, is a three-dimensional object that describes motion and distance and relative location in a two-dimensional plane. We live in 3 dimensions, so it wouldn't be a donut, it would be a hyperdonut, even if it was a donut. But even so, there are toruses that are not shaped like donuts. So it's better to not think of the shape as the universe as like an actual 3-dimensional shape, because first of all, you're going to have to think of a higher dimensional shape anyway, and that's easy enough to break your brain. But rather, just think of it as a collection of properties that we have observed. First property, the angles of a triangle add up to 180 degrees, so it is likely flat. Second property, based on data that we've gotten from the cosmic microwave background, it appears as if you were able to go infinitely in one direction, then you would eventually loop back to your origin point. And if you were to draw 2 lines out into the universe and let them loop back to their origin point, and they ran parallel to each other, they would never intersect. This is just behavior of the universe that we've either observed or extrapolated. So what we're doing is describing the properties of space, the properties of locality in the universe. We're not necessarily saying, hey, the universe is shaped like a donut. We are just telling people what the properties of our 3-dimensional space is. Like, if it was curved, if it was spherical in some nature, then 2 parallel lines would eventually intersect, and we don't see evidence for that. Or the angles of a triangle would add up to more than 180 degrees, and we don't see evidence of that. Even when we measure a triangle from Earth to points in the cosmic microwave background. So yeah, we're not really mentioning a shape, like a static shape that you could reach out and hold, like a donut that you could take a bite out of. We're just using the donut as a 2-dimensional representation of our 3-dimensional space. If our universe were toroidal, it would be toroidal in however many dimensions our universe has. Which to most physicists is 3 in a dimension of time, but ask a string theorist and they're going to have a different opinion. But the toroidality of the universe isn't affected by those extra dimensions. Or at least I should say the non-curvature of the universe, because again, the torus is just one model of non-curved universe. There are other hypotheses out there that do describe our behavior. That's why it's not accepted as a theory, it's still just a hypothesis. But a popular one, and one that many scientists agree on, and one that I personally think is plausible.